To learn about production of an egg cell, it helps to understand that when people talk about oogenesis, there are actually two parallel events that occur. There's oogenesis, which is the meiotic events. That's the production of the egg cell. That's what I'm going to talk about in this video. And that's what's depicted here too. You know, the one cell dividing into two cells, dividing into four cells. Just the meiotic events giving rise to the egg. Now, when that happens, this oocyte, this developing egg cell, is not alone in the ovary. It's actually surrounded in a cellular package called a follicle. And so as the meiotic events occur, what happens is the multicellular follicle that contains this cell also gets bigger and bigger as time goes on. And that's follicular maturation, which I'm going to talk about in a different video. So the timing of the meiotic events of oogenesis might be a little unexpected because oogenesis actually starts prior to the person being born. This blue box represents the events that occur prior to the person being born. My black line represents childhood, a time when the ovaries are quiet. And then starting at puberty, what will happen is oogenesis will continue where it left off. Let's take a closer look at that. So the way this works is that prior to the person being born, there are cells that will populate the ovaries called oogonia. Here is an oogonium, singular. And these cells that populate the ovaries, the oogonia, divide by mitosis. That's regular cell division. And they divide by mitosis just to give us a large population of oogonia. There's about 6 to 7 million oogonia within the ovaries at about month 5 of development. Prior to the person being born, what happens is that all of these oogonia together as a population will start to undergo meiosis. And what I mean is that these cells will enter prophase 1. So in other words, they enter into meiosis, except they don't even divide once. They don't get that far to a cell division. So when a female is born, that female is born with a population of primary oocytes. So the primary oocytes are the cells that have started to undergo meiosis. Those are the ones that could eventually turn into an egg cell. And by the time a person is born, already many of these cells have died off. So a female is born with about 1 million primary oocytes per ovary. Then, starting at puberty, when hormones start to wake up these primary oocytes that have been waiting in the ovaries, they'll continue in meiosis where they left off. And so when hormones stimulate, what will happen is a population of primary oocytes will respond to that and they'll continue meiosis. They'll pick up where they left off, basically. And so with oogenesis, as far as timing goes, just prior to ovulation is when the first meiotic division occurs. So the one cell that has 46 chromosomes is going to divide into two cells that have 23 chromosomes each. So genetically, these two cells have the same number of chromosomes, but notice that the division of cytoplasm is really unequal, right? And so it looks like this cell hardly got any organelles or cytoplasm, and this cell got them all. So the big cell that you're putting all of the resources into is known as the secondary oocyte. The genetically equivalent cell that didn't get any cytoplasm and it's small, that's known as a polar body. And so the secondary oocyte is the cell that gets ovulated. And it's also the secondary oocyte that could be fertilized, surprisingly. And so once a secondary oocyte leaves the ovary, if it's fertilized, then it will undergo the second meiotic division. And that second meiotic division is also going to be an unequal division of cytoplasm, giving us another polar body, the full ovum nucleus. And like we were saying, you know, surprisingly, the ovum only exists when it's fertilized, actually. So there would be the ovum nucleus and the sperm nucleus waiting to combine. And then as far as the first polar body goes, that first polar body is going to be clinging to the secondary oocyte at the time of ovulation. And it may or may not undergo the second meiotic division if it lives long enough. It could undergo the second meiotic division, giving us 2 more polar bodies, or if it dies off, then obviously it wouldn't divide. Whether that polar body divides or not doesn't matter to us. It doesn't matter because these cells can't become fertilized. These cells will eventually die, and so whether it divides or not, it doesn't make any difference at all. And so those are the meiotic events, the events of oogenesis.